Now we're going to talk about savings plans. There's two ways that we can earn interest when we save money, and the first that we're going to talk about is simple interest. Simple interest isn't really that common, but it is still around, and so it is still important. Simple interest, we're going to use a calculator function to do compound interest. Simple interest is not a function of the calculator. In fact, the only way that you can do it is by formula. So you want to pay attention to this formula here. Interest equals principal times rate times time. Remember, when the letters are bumped up next to each other, that means multiply. The P is principal, that's the amount that you borrow, or in this case, this is the amount that you invest. R is the APR, the annual interest rate. Since we are putting this into a formula and just typing it into a calculator to do the math, you want to change that interest rate to a decimal, and T is the time in years. So we've got 3 questions here about Trevor. Trevor wants to invest $1,000 in an account that earns simple interest at an annual rate of 5% a year. So first we're going to figure out how much money does Trevor have if he leaves the money alone for 1 year. So interest equals, the principal is the amount he deposits, times the interest rate is 5%. I want to change that to a decimal, times time is 1 year. So the amount of interest that Trevor will earn in 1 year is $50. Now, what if he leaves the money alone for 2 years? If he leaves the money alone for 2 years, then this first one didn't happen. Interest is only computed one time, and that's at the end, if we're talking about simple interest. So he puts in $1,000, he gets 5% interest a year. This time he leaves it for 2 years. The interest that he gets back if he leaves his money alone for 2 years is $100. And if he leaves it in there for 3 years, again, the first 2 things didn't happen. Simple interest is computed one time, only one, and that's at the end of the period. So this time he earns a total of $150 worth of interest. Simple interest, you only pay interest on the actual investment amount. So each time we only got interest on the original $1,000. We didn't get any interest added and then earn interest on our interest. That's what compound interest means. Now the second question is to find the accumulated balance. Usually we don't really care how much the actual interest amount was. We want to know how much money we have total at the end. So that accumulated balance, I'm just going to use A for accumulated balance, is the principal that he started with plus whatever interest that he earned. So for 1 year, his accumulated balance would be the $1,000 he started with plus the $50 interest. So at the end of the year, he would have $1,050. If he left his money alone for 2 years, he would have the $1,000 he started with plus the $100 interest, which means his accumulated balance would be $1,100. And for 3 years, his accumulated balance would be $1,150. And that's simple interest. The rest of this section, and actually the next couple of sections, are going to deal with problems that have compound interest. So the next few sections are all going to deal with an app on our calculator that essentially means we're going to have to fill this in order to be able to use it. Now, there are simple interest formulas. There are compound interest formulas. Simple interest, we didn't have a choice but to use the formula. Compound interest, you can go on YouTube, you can find some fantastic formulas about how to compute compound interest. The thing is, they're a little hairy, and nobody in real life is actually going to use them. If you have to figure out what your payments are going to be on a loan, or you want to figure out how much money you can make back on an investment, and you want your interest compounded, everybody's going to use a computer program, or they're going to use an applet, or they're going to use an application like we have in our calculator. So instead of worrying ourselves with a bunch of fancy arithmetic, we're going to worry ourselves with what we call critical thinking. And that is being able to look at a problem, figure out what it's telling me, and put all those pieces in the correct spots. Now, the calculator is going to do all the math for us, but it can't do the math unless we tell it the correct information. So your real job over the next few sections is going to be to understand what all these little symbols in the list stand for. So that's what we're going to talk about first. If you could fill out this chart, the calculator's got the math under control for you. So the I% stands for the interest. And because it has the percent sign with it, we're talking about a friendly place to list our interest, because the percent sign means I don't have to move my decimal point. If a problem says it's 5% interest, I just type in 5. If it says it's 6.2% interest, I just type in 6.2. These three, these are my money. PV stands for present value. That's the money I have at the beginning of the problem. Doesn't necessarily mean today. It means the money I had at the beginning of the problem. If I skip down to FV, that's the money that I have at the end of the problem. Again, I could have started the problem 5 years ago and wanted to end it today. The future value could be today, even though it's called future. Don't hold too much stock in the words present and future. Think beginning and end. Present value and future value, those are a one-time deal. This the lump sum at the beginning and the lump sum at the end. Sometimes we don't talk about lump sums. Sometimes we need to talk about repeated payments or repeated deposits. That's where the payments come in. Payments are money that's paid repeatedly, not just one time. Now the PY and CY, that /Y means per year. The P stands for payments. The C stands for compoundings. This is payments per year and compoundings per year. These two have to match. If they don't match, it's kind of out of our league. So we may not actually be making payments, but the compoundings are going to be our payments. In other words, that's how many times interest is going to get added to our account. Now I skipped the N at the top. N is the total number of compoundings in the entire problem. The number of compoundings in the entire problem. So N is going to be the number of years that a problem goes on times whatever your CY and PY were. So N is always going to be figured out by doing a multiplication. How many years the problem lasts times whatever you put down there for your CY. Now, one other thing, whenever you're using an accounting program, usually, now they can be getting more sophisticated nowadays, but you list cash outflow as a negative, and you have receipts of money listed as a positive. Our calculator isn't that fancy dancy. It's pretty fancy, but we need to watch our signs in order to get the correct direction of money. Kendra invests $1,000 in a savings account with an annual compounding at a rate of 6% per year. Find the balance at the end of 5 years. Now we're going to concentrate on filling out the chart. You need to see a sheet that you have in D2L to show you how to do the actual operations of the calculator. I'm not able to post them here using this program. So I will give you the answers to each of these. So when you go back and refer to your sheet, you can make sure you've gotten the correct answer. But we're going to do that separately. We're going to talk about, can you fill this out? Because if you can't fill this out correctly, it don't matter what buttons you push. It's not going to give you the right answer. So she invests $1,000 in an account, annual compounding 6%, find the balance at the end of 5 years. So we're looking for the money at the end, which means the $1,000 is the money we have at the beginning. Now Kendra, think about it as a physical thing. Kendra is not receiving $1,000, she is giving it to a bank. That is a payout at the beginning. So she pays out $1,000 at the beginning. We want to find the balance at the end, so this is what we're looking for. She has an annual compounding rate of 6% a year. 6% annual compounding. Annual means once a year. We want to know how much she has at the end of 5 years. So N is going to be 5 years times 1, which is just 5. The 1 coming from my CY. We're not making any payments at all, so that's just 0. Once you see how to work the calculator program, the answer you get for your future value should be $1,338.23. I want to make sure you get the answers so that you could check it later. Or perhaps you've already looked at the sheet and you can work along with me. Right now your concentration should be, can I fill this out? So let's try that again. $40,000 invested at 8.5, 30 years compounded annually. You should be able to follow along with what we did on the last one for this one. So if you'd like, just pause me for a moment. $40,000 is invested at the beginning of the problem. That's negative because it's an investment, and it's PV because it's at the beginning. We want to find the accumulated balance. That's how much we have at the end. We have compounded annual interest of 8.5 for 30 years. That's 30 times 1. That's a times, not a point. And we're making no payments. For future reference, the answer to this is $462,330.07. What changes when we have daily compounding? Daily is 365 times a year because there's 365 days in a year. $2,000 invested. Daily compounding of 3%. We want to find the accumulated balance. we're making no payments, and we want 5 years times 365. I don't need to know how much that is, because I can just type in 5 times 365 and the calculator will figure it out for me. The answer to this will be 2365. Monthly, 12 times a year. $10,000 deposited, 6.2 monthly compounding for 5 years. No payments made. Solve for future value. Continuous compounding. Continuous means all the time. We don't have a number for all the time, but we need to know how many times continuous is in 1 year. If we take 365 days times 24 hours times 60 minutes, we get 525,600, and that is compounding every minute, and that's what we use for continuous compounding. Once every minute is close enough to continuous. So my PY and CY are 525,600. Which means 5 years of continuous is 5 times that, and the rest of this is as you're used to. 2,000, APR of 5%. We're solving for how much we have at the end, and we are not making any payments yet. This would give you 2568.05. You want to have $75,000. You don't want to have it at the beginning, you want to have it at the end. We want to know how much we have to invest at the beginning. If I want $75,000 at the end, and I want to receive $75,000 at the end, not to pay it, that's a future value of $75,000, and that's positive. I want to retire in 35 years. So I choose an account with quarterly compounding. That's 4 times a year. An APR of 5%. How much of an investment does this plan require you to make to reach your goal? Now, I'm not wanting to make periodic payments. I want to make a one-time investment. So I'm solving for present value. Payments are still 0. This will give me $13,175.19. Now, if you're following along with the worksheets, you've got like 8 problems, is it? 7 problems to practice that, and I believe I've got the answers already attached. When you finish that, we can come back to annuities. Annuity is what happens when you don't have $10,000 laying around to just sit in the bank for 40 years. Instead, like most people, you can only afford to put aside a certain amount of money each month. So an annuity is a series of equal periodic payments. So it's kind of like we promise ourselves we're going to set aside this amount of money each month or each pay period. Remember, we assume payments and compounding periods are the same. So it's in this section that really comes to fruition. Eileen starts at age 25 depositing $50 a month. If she does it $50 a month, that's not a one-time at the beginning investment. That is a payment. So she makes payments of $50 a month, and she starts with no lump sum. Now she has a retirement account that's going to earn 8%, and she does it $50 a month means she makes 12 payments a year. Even though it didn't say anything about the 8%, if she's doing 12 payments a year, we assume she's getting compounded 12 times a year. How much will the IRA contain at the end? That's what we're solving for. From the age of 25 to 65, that's 40 years times 12 times a year. Her IRA would contain $174,550.39. Woohoo! Go, Eileen. Now the last one. Same principle. Except I want to have $2 million at the end. And I want to receive $2 million at the end. Make sure you count your zeros correctly, because when you type them in the calculator, you can't put commas. So we got an APR of 9%. We want to retire in 30 years. And we want to deposit monthly. Deposit monthly means we are not making a lump sum at the beginning. We're making 12 payments a year. Remember, that goes into 3 places. And we're solving for how much our monthly payments have to be. Our monthly payments to get $2 million would be $1,092.45. And you have some more practice problems that you can do. Again, in Shelby, your answers are attached. And please see the instructions in D2L for how to use your calculator appropriately to solve these.